Hello, physics students, and welcome to this screencast by yours truly, Mr. Welch. I had to say that. I said it in the first two screencasts that I've made, so I thought I'd keep the trend going for you, because some of you think it's funny when I say that, so I thought I'd throw it in there. Anyway, as promised, I have a screencast here to continue on from what we talked about in class today, and probably to reiterate a few things that we did in class today. I know I went pretty quick. I wasn't expecting some of the stuff to take as long as it did, and that's still something that I'm trying to learn as a teacher. So this screencast hopefully will reiterate some things and then bring to light some new things that we need to know for this unit. So what did we talk about today? The big thing was energy, and we described energy as the ability for an object or a system to do work. And one thing that I failed to mention was that that energy is a scalar quantity. We've been dealing a lot with vector quantities where we have a magnitude and a direction, but energy is a scalar quantity, so we just need a magnitude. And that means different things for the different types of energy that we're going to talk about, and we'll get into that in this screencast. So another thing that we discussed was energy. There's a lot of different types. There's a bunch of different types of energy, and that's a critical thing to know because we're going to talk about different types in this class. We could talk about hundreds of types of energy. Well, maybe not hundreds. That's probably an over exaggeration, but we can talk about a lot of different types. We started out today by talking about mechanical energy, and mechanical energy, we said, was energy an object has due to its relative position and or its motion. And I say and or because an object could have energy based on its position, an object could have energy based on its motion, or it could have a combination of the two, depending on the scenario. And we're going to get into problems where we see that combination of energies together. So we talked about mechanical energy, and we started talking about a type of mechanical energy, and that is potential energy. And the broad definition for potential energy is stored energy that an object has due to its position. So potential energy is stored energy that an object has due to its position. Now, you're probably sitting there, and you probably thought this in class today. You're like, well, Mr. Welch, what? I don't really get what stored energy is. Okay, you may or may not have been thinking that. Well, stored energy, you can think about it like this. That object, based on its position, it could do work. It has the potential to do work, but it might not quite be doing that work yet. It has the potential to, but it's not quite doing it yet. When we began talking about one specific type of potential energy, and that was gravitational potential energy. And what we say with gravitational potential energy is that it's the energy, the stored energy an object has based on its vertical distance from some reference point or from some reference frame. We had a mathematical definition for gravitational potential energy, just like anything we do in physics. We said that PE, and we could boy, I can't talk, it's been a long day. We could subscript that with a G, so we could say potential energy, gravitational potential energy, is equal to mass times gravity times height. Now, earlier in this screencast, I mentioned that energy is a scalar quantity. We usually think that the acceleration due to gravity has a direction, right? It's always in the downward direction. Well, because energy is a scalar, we don't really care. We don't really care about the negative we throw on the acceleration due to gravity. So in this unit, when we use gravity, the acceleration due to gravity, we're going to say it's 9.8 meters per second squared. So gravity is going to be 9.8 meters per second squared. But we have to be careful when we're talking about gravitational potential energy, because in class today, I mentioned that potential energy could be positive or it could be negative. And that doesn't really make sense when I say that energy is a scalar, because when we think of scalar, we just think that Oh, it's just the magnitude. So it's just always a positive. But we have to be careful. What is the definition for gravitational potential energy? It's the stored energy an object has relative to some reference point or to some reference frame. So we have to take into account where that object is in comparison to a reference frame. So let's look at an example here. We have a cliff. We have the ground. Let's say Mr. Welch is up here. Okay, Mr. Welch, he's smiling. I'm having a good time. All right. Now our reference point, I'm going to say, is the ground here. Okay. Our reference point, or our level 0, is the ground. So when we want to look at whether potential energy is positive or negative, we start at our reference point. We start at our reference frame. So we're starting here, and then we have to travel towards the object, or we have to look towards the object. So in this case, we have to go up. So we say that this is a positive height. A positive height. So what does that mean? What does that mean for our gravitational potential energy? Well, that means our gravitational potential energy is positive. It has to be, because mass is never negative. We're saying that gravity is not negative anymore because energy is a scalar. We don't care about direction. But Mr. Welch here, me, in reference to this, is above the frame of reference. So we say that it's a positive height. Therefore, our potential energy is positive. Now, what if we have a new scenario here? What if we have a different scenario? We have our same cliff, but instead of me standing on the top of the cliff, I'm standing on the ground now. And I'm saying that the point of reference in this scenario is the top of the cliff. So again, starting from our reference point, we go down. We go towards the object, or in this case, me, Mr. Welch. So me, in reference to the reference point or the reference frame, I am below it. It is a negative height. So what does that mean for our potential energy? That means it's negative. Okay, negative. I hope this makes sense. It is a little goofy to think about that I'm saying that energy is a scalar, but yet we can have positive or negative. But it's really important to keep in mind the definition for gravitational potential energy. It's stored energy due to the vertical distance from a reference point. From this reference point, I am below. So it's a negative height. So we talked a lot about gravitational potential energy. There is another type of potential energy, and some of you mentioned it in class today. The other type is elastic potential energy. Okay, and our definition for elastic potential energy is stored energy as a result of deforming an elastic object. And now you're probably like, well, Mr. Welch, what's an elastic object? Well, we dealt with springs. Springs are elastic objects. This rubber band is an elastic object. All right. You see, I can deform it. I can do this sweet thing and shoot it at the camera. So this is an elastic object. It can deform. I can stretch it. I can compress it. So it is an elastic object. Now we have a mathematical definition, of course, for elastic potential energy. We say that PE, and I'm denoting this with S. I'm denoting elastic potential with an S, because most often we think about springs when we talk about elastic potential energy. So we say that potential energy elastic is equal to 1/2 kx squared. Now our x, I'm going to start out with x. We're going to get back to k. Our x is any deformation of this elastic object. So here it is in its relaxed position. I'm stretching it. This is some x. This is some displacement of the elastic object. Okay, this is its relaxed position. I'm compressing it. This is some displacement of the elastic object, okay? So x is just the distance of deformation. Now what about this k? Well, this k is what we call a spring constant. And a spring constant is actually a physical property. Okay, it's a physical property of a spring or of a rubber band. It's unique to that spring or that elastic object, and it never changes. So this rubber band, it has some spring constant. I don't know what it is, but it's a physical property of this spring. And you'll be given that in problems that we solve with elastic potential energy. Last thing I want to point out is, unlike gravitational potential energy, elastic potential energy can never be negative. Why is that? Well, our spring constant is never negative. And let's look at our x term. Let's look at our x term here. It's being squared. Okay? So no matter if I stretch this, and let's say that if I stretch it, it's a positive x. If I square it, that's going to be a positive number. Now let's say if I compress it, we'll say that that's a negative x, okay, or a negative deformation. Well, if I square a negative number, I get a positive number. So elastic potential, it can never be negative, ever. So that's where it's different than gravitational potential. All right, I know I covered a lot. I covered it quickly in class today, pretty quickly in this screencast. The advantage you have is that this screencast you can go back and watch and take thorough notes. This is just a brief overview of potential energy, introducing some types of energy. We're going to go much more in detail. We're going to learn how to solve problems with elastic potential, gravitational potential. All right, so I hope you took good notes in this screencast. If you have any questions, always come talk to me. Remember, you can always rewatch this screencast to fill in any holes that you might have in your notes. Thanks for watching. We'll see you soon.